Today we're going to be talking about transformations of parent functions. So if we're adding or subtracting a number to our equation, it is going to be a vertical translation. Under function notation, I've written out what it might look like using x squared as the parent function. Alright, if you have the plus or minus a number inside the parentheses, so where x squared is, between the x and the square power, it's going to be a horizontal translation. And it's going to move the opposite way of what you look like. So if it says plus c, it's to the left. Let me show you why real quick. If we have x squared, okay, the origin is at 0, 0. If we put x plus 2 squared, the only way to get back to the 0 for our y value is to make x negative 2. That's why it moves the opposite way of what it looks. Okay? If there's a negative out front, it's a reflection over the y-axis. A negative inside, reflection... I said that backwards. If there's a negative out front, there's a reflection over the x-axis. If there's a negative inside the parentheses, it's a reflection over the y-axis. If there's a variable outside of your x that is greater than 1, it is a vertical stretch. If it's less than 1, it is a vertical compression. Let me show you that. The best way I can explain this to you is getting closer to 0. So we have x squared, or getting closer to infinity. If you look at 1, our y value is positive 1. If we type in 9, so again, try to make this go to infinity faster for a stretch. If we go to our y value of 1, now it's only taking about 0.3 to get to 1. Okay? If I do 1/9, I have to go in the x value all the way to 3 to get my y value of 1. So a vertical stretch is going towards positive infinity on the y faster than the parent function, okay? Alright. Given the name of the parent function, give the name of the parent function, and describe the transformation represented. I'm only going to do a couple of these. Number 1, the parent function is a quadratic, and it is a vertical translation. This is also called a vertical shift. So it's going to look something like this. I'm graphing this pseudo-accurately just to get the shape of the U. Alright, let me shrink this just to get it out of the box. Now I'm going to do number 4, and then I'm going to show you number 3 in Desmos, because you can have Desmos on the final exam being Math 3 in North Carolina. Alright, number 4. The parent function of this is a quadratic. And it looks like this. That's your x squared. Okay? We have a negative out front. That negative is a reflection. Ignore that I underlined the 2, I didn't mean to. Is it as a reflection over the x-axis. So now our graph looks like this. This is y equals negative x squared. The 2 is going to make it go in towards infinity faster. This is a vertical stretch. So it's going to look something like that. And yes, I'm just guesstimating. Alright. This +1 here is going to move our graph to the left 1 unit. Oh, wait a minute, I forgot. This is y is equal to negative 2x squared. So it's going to look like this. And that's y is equal to negative 2x plus 1 squared. Yeah, I know, that one's hard to see with those colors. I apologize. The last part is the +3. Alright, there's a transformation so far. I'm going to have to erase those. Actually, I'll do this. Just for the sake of this lesson, I'm going to temporarily move all of this to that graph. Okay? There's all of one so far. Then we have this +3. So that's going to take our multicolored line and move it up 3 units. So there's the vertex. And it's going to go to infinity faster than the parent function. Okay? So, to recap, we have a reflection over the x-axis, a vertical stretch. We have a horizontal shift. And then lastly, we have a vertical shift. Again, shift is interchangeable with the word translation. And I just tried to combine how to spell the two words. Okay. I'm going to do number 3 in Desmos. All you have to do is type it in. -3 to the x power -2. Once you have it, you can copy it down. Again, pseudo-accurate. Just accurate enough for you to see the picture. Parent function was exponential. Alright, if you'd like to do 2, pause it. 5 and 6, pause it. 7 and 8, pause it. Okay. Last questions and I'm done. Graph these functions given the description. So the absolute value, so we have y is equal to, absolute value has absolute value in x, a vertical shift up, so that's going to be +5 on the end, a horizontal shift to the right, that's -3 inside. Linear, y is equal to x, vertical stretch / compression of 2/5, we're just going to put that there then. Logarithmic, y is equal to log of x, flipped over the x-axis, negative, shifted down to -2. Exponential, a stretch by 8. Exponential, there's parent function, stretched by 8. 8 times it. Quadratic, x squared, a vertical stretch by 5, a horizontal shift left 8, so +8 inside. Which graph best represents the function 2x squared minus 2. Look at the minus 2. This one's up. It's incorrect. This one's to the right. It's incorrect. This one's up and flipped over. It's way incorrect. B's your answer. It's going down 2. Alright, we're done for the day. I'll see you in the next video. Well, you know what I mean.